Hello everyone, myself Harsha and my teammate Aditya. Today we are both discussing about the AI project SMS spam detection using the TensorFlow. The project is about to building a Python based system to detect spam messages using TensorFlow. Now coming to the objectives of the project. The first objective is to develop a machine learning model to classify whether the message is spam message or not. The second objective is to utilize both traditional and TensorFlow-based deep learning methods. The third objective is to assess model performance to identify the best spam detection strategy. Here are the project approaches. Here we use the machine and deep learning algorithms such as multinomial Navi-based vectorizer, TensorFlow, and Keras, and the libraries such as NumPy, Pandas, Matplotlib, and Seaborn. And now coming to the project methodology. Initially, we are importing the all the necessary libraries such as NumPy, Pandas, Matplotlib, Seaborn, and TensorFlow. After importing all the necessary libraries, we are just loading the data set using Pandas, the Pandas and read underscore CSV function. It is the function which allows to read the data set, and after uploading the dataset, we are just constructing a baseline model using the multinomial Navi-Bayes algorithm and evaluating its performance by generating a confusion matrix. After generating a confusion matrix, we are just developing in text vectorization and embedding layers using the TensorFlow. After that, we are just implementing transfer learning with a universal sentence encoder to enhance model performance. Now coming to the expected deliveries. The first deliverable is a pre-processed dataset. The second deliverable is evaluation report, and the third deliverable is training deep learning models, and the last deliverable is to comprehensive and evaluation metrics. Now coming to the code evaluation. Here we imported all the libraries. Here the NumPy is used for data manipulation and numerical computation. And coming to Pandas, it is used to read the data set. And third, the Matplotlib, it is used to plot the data plot different types of visualization such as bar plots and etc., which helps to visualize the data. And coming to Seaborn, it helps in creating statistical plots and helps to explore relationships of the data. And coming to the TensorFlow, it is a deep learning library that provides tools for building and deploying neural networks. And last, Keras, it simplifies the use of TensorFlow to use abstractions for building and training the models. And for this project, we have used the dataset spam.csv, and here we uploaded into the drive. And now coming to the next snippet. Here just we are reading the dataset spam.csv. This is my dataset path. So here after reading the dataset, I was just storing all the data in the form of data frame into the variable df, and here the df.head describes that just we want to display only the first 5 rows of the dataset. And coming to the next code snippet, here just we are dropping the unnecessary or unnamed columns in the dataset, and we are renaming the required columns to label and text. And again we are just displaying the first 5 rows of the dataset. And here and in this code snippet, we are just grouping the column label and calculate the size of each group, and then plots a horizontal bar using matplotlib. And now coming to the density plot. In this code, just we are calculating the length of each text entry in the data frame and plots a density plot of text lengths, comparing different categories from the label column. Here we have two type of label columns. One is ham and the second is spam. The labels ham is denoted by the blue color, and the label spam is denoted with the orange color. And here coming to the counter plot is just shows the frequency of unique values in the label column. And here we are just calculating the average number of all tokens in the sentences, such as like it just it calculates all the average number of words per text message in the columns, such as is first it does by splitting each text into individual words, counting them. After that, after counting all these after that we are summing all these counts across all the messages and storing the variable average underscore words underscore length, and we are just displaying the average number of tokens. Here it is 15. And coming to the next code, here we are calculating and printing the total number of unique words across all text messages in the text column. Here there are 15,585 unique words. And in this code, and now come in this code, we are from sklearn model, we are importing the training test split. Here we are converting text and label underscore length columns in the data frame into numpy arrays, and we are creating a new data frame, new underscore df. From these arrays, we are just splitting this new data frame into uh, training and test sets with a size 20%, which is 0 0.2, and it also prints the shapes of the training and test data sets. And coming to the next code snippets, again here from the sklearn we are importing vectorizer, multinomial Navi Bayes, classification report, accuracy score. Here just we are setting up text classification using a Navi-based model by first converting the test data from training and testing into vectors, and it trains a multinomial Navi-based classifier on the vectorizer training data to make predictions. And here we are just calculating the accuracy score and as well as the classification report. And here, these are all the evaluation metrics: precision, recall, F1 score, and support. Now coming to the confusion matrix. The confusion matrix is is used for a trained baseline model on a vectorized data set with true labels. The main use of confusion matrix is to assess the model's performance by visualizing true positive, true negatives, false positive, and false negative values. And coming to the next code, it just it just shows all the model evaluation metrics such as accuracy, precision, recall, and F1 score. The next will be continued by my teammate Aditya.
Hi, hello everyone. Let me continue from this code where we have started. So this code snippet sets up the text vectorization layer from TensorFlow's Keras library. It is used for pre-processing text data. So basically, it configures the layer to convert text to lowercase, and it strips the punctuations and generally it transforms to integer sequences. The maximum number of unique tokens it can handle is set to the total number of unique words in the data sets. So we'll be storing that using a total words length variable. And the length of the output sequence is set to average number of words per text message, and we'll be storing it in average words length. The layer is then adapted to the training data, X train, allowing it to build a vocabulary and prepare for text transformation based on the training set. For this, the output shows the result of applying the text vectorization layer to the sentence. Let's say, for example, if we consider an example of a text sentence like this is a AI final project. This is a text. This is just a text. Now, this layer has converted the sentence into an array of integers where each integer represents token in the layer's vocabulary. The sequence is padded to length of 15, which is a specified output sequence length, with zeros filling in positions where there are no words from the input sentence. Each number corresponds to a unique word, with one typically representing a word outside the topmost frequent tokens specified by max tokens, often an out of vocabulary token in this context. Now, let's move on to the next code snippet where the code initializes an embedding layer for a neural network using TensorFlow's Keras library, which maps each word in a predefined vocabulary for a specific size up to 128 dimensional vector. The layer is configured to handle sequence of lengths, and then it initializes the vectors uniformly. This setup helps in learning dense representation of words, capturing their semantic meaning during model training. And let's go to the next code snippet where it constructs a neural network model using Keras API designed for binary classification for text data. The model begins with an input layer that takes in strings, applies a text vectorization layer, convert these strings into integer sequences, and then uses an embedding layer, transform these sequences into dense vectors. It includes a global average pooling layer to reduce dimensionality, followed by a flattening step and a dense layer with a ReLU activation for non-linear processing. The final output is produced by a dense layer with a sigmoid activation function, which is ideal for binary classification. The model is compiled with the Adam optimizer, binary sorry, binary cross entropy loss, the label smoothing to help prevent overfitting, and it tracks accuracy as a performance metric. So the next line of code displays a summary of neural network model 1. So it just summarizes what the model 1 process, providing details about each layer, including types, shapes, number of parameters in model, then which helps in understanding the architecture and parameters count of the network. So the next script of the Python defines three main functions for managing a machine learning model using TensorFlow's Keras framework. The compile model function. It set up a model with Adam optimizer, binary cross entropy loss, and tracks accuracy as a metric. The fit model function. So it trains a model on provided training data for specified number of epochs, validating performance on test data. The evaluate model function. So it assesses the model on given data, calculating and returning metrics like precision, accuracy, recall, and FN score. Summarizing all this and the model's performance, it forms into a dictionary format. This is why all these functionalities are used. And if we go to the next code snippet, so what it does, it actually constructs a more complex neural network model. Same as before, also uses Keras API for text classification. It begins with input layer for string data, followed by a text vectorization layer, and then it integrates a sequence and an embedding layer to map these sequences to dense vector. Then, so what it does is it includes a two bidirectional LSTM layer with 64 units in each of them, which process the input sequence in both forward and backward direction, as the name says, like bidirectional. So it captures contextual information and then it flattens the output, applies a dropout regularization, and passes it through a dense layer with relay activation. Finally, it ends with the output layer using sigmoid activation function for binary classification. The model is compiled with the same as the Adam optimizer and binary cross entropy loss and trained for 5 epochs on provided data. So the next code which we'll be seeing will utilize TensorFlow Hub to create a sequential model for text classification and it incorporates universal sentence encoder, which is a USE, to embed text input into numerical vectors, followed by dropout regularization and two layers for classification, ultimately training the model over 5 epochs. And finally, the final code snippet, it will evaluate the performance of all the multiple models that we have seen earlier in this code, which includes a multinomial naive Bayes, custom vector embedding, bidirectional LSTM, and transfer learning with a universal sentence encoder. So it uses all these models for the performance on a test data set. So adding all together those and then the aggregating result into a data frame for comparison. So we can see the data frame for the comparison where we can see the accuracy, precision, recall, and F1 score for different models and how it varies on each model. So this way we can see the quality of message if it is a spam or a ham based on these metrics. So this is as our projects end here, and this is we have done to differentiate spam and ham using TensorFlows. So thank you, and this is the end of the video. Thank you.